All right, everybody. I just wanted to do a quick um, retake of the last game that we did together. I felt like it didn't really do justice in class. So this is a setup. If you have any questions about the setup here, go ahead and watch those last few minutes of class. But when we got to the questions, I think it was a little bit jumbled, and I apologize for that. So wanted to start where we left off, start with the setup here. You can see we've got our dot diagram, we've got our main webs, we've got an example um, diagram here, and then we've got each of the rules represented. I'm going to go ahead and jump into the questions now, and we'll go through three questions together. First question is a conditional question starting with if. And whenever I encounter these if questions, I will often redraw the main diagram to include the new information. And I like to label them. So I would, put a question number here. We don't have question numbers. I'll pretend this is question one. Question one, J before L and S before P. And I want to have this written out on my scratch paper so that I can see at a glance whether the new conditions would be applicable on future questions or not. Sometimes they work on future questions, sometimes they don't, but it's always helpful to have this reminder of what caused me to come up with a diagram that I've redrawn for a specific question. I also want to note whether it's a must be true or could be true. This is must be true, so I'm looking for something that is forced into place, constrained down to one option in a way that didn't happen previously. And we'll say that happens pretty early in this case, but I do want to go ahead and do the full diagram, even though on test day, you might decide to stop after you've found that first inference that happens where things are kind of locked into place. Okay, so look at my main diagram, and I know that I'm going to be paying attention to the relationship between J and L and between P and S. We go ahead and do this one variable at a time, try to be really careful, make sure that I only have each thing shown once. H before J and L, so H before J, then before L. This doesn't tell me anything about Q. Q is unchanged here. So the only thing I still know about Q is that Q is before, that J is before Q. I get to S, and L and Q are still both before S. So I'm going to make sure that they converge there. Now I have another new idea, another new variable. I've addressed J and L. I need to include S and P. So I'll draw S before P. So that resolves that uncertainty about the relationship between S and P. And then I still have to account for V. V is unchanged by the new constraints. So V goes here. If I try to write this on a new diagram, which is often useful, I can see that H still has to be first. Now there's only one option for what comes immediately after H instead of two options as before. There's only one option, H and J. I'm not going to worry too much about the spots in the middle. I go back to the end again, and I can see that even though S is more popular than P, that doesn't force P to come last because V is still unconstrained in terms of what comes after it, right? There's three things that have to come before V, H and J and L now. So there's more things in front of V than there used to be. But it still is possible for V to come at the end. So that means my last position could be P or V. Okay, so with this diagram, it might be tempting to try and fill in some more of the spaces in here and try to include some of this information about the way that L and Q and V and S relate to each other, but it's really not important when we have a must be true question, at least on the first pass. On the first pass, I'm just going to look for something new that's been locked into place. And of course, J being second is that new thing, which is great. Now, if I needed to rule out some of the other answers, right, about B, C, and D, and E, I could do that. J can't be third because it has to be second. Do I have to put L third? No, I could just as easily put Q third because it's one of the variables that only has two things in front of it. That eliminates C. On the other hand, if I wanted to put something other than Q third, I could just easily put L third, so that eliminates D. And then we've already discussed why P doesn't have to be seven. Okay. Again, on game day, you don't have to eliminate all the answers. Just kind of you want to hunt for the correct answer. And all those must be true questions, you want to look for one that's been locked in most cases. All right, so that's the first question. Second question is just a straightforward absolute question. We've got what can't be third. Now, there's two ways to think about what keeps something from being third when you've got these webs. Either there are too many variables that have to come before something on all of the chains that's a part of. We got to look at all of the chains that it's a part of, but there's too many variables that come before it. And of course, if we're talking about the third position, right? To be forced out of the third position, you'd have to have three or more things that happen prior to that variable in order to keep it from getting as early as third. Anything that has fewer than three things on its chains can go first or second or even third. Anything that has more than three variables to its left on its chains can't be as early as third. So let's take a look at our variables and think through which ones have more than three things to the left of them. Obviously, H has 0 to the left of it. J has 1, L has 1. Q has two things to its left, so Q could go as early as third. V also has two things to its left on the chains that it's part of, so it could go as early as third. S has four things to its left, right? We got to make sure we pay attention to all the chains that it's part of. So S has 1, 2, 3, and 4 things in front of it. That means that S will never be as early as third. It would have to be fifth or later. And P has 3 things in front of it, so it also can never be as early as third. That's one way, and our correct answer is one of those variables that has too many things to its left in order to show up that early. The other thing that could happen, and this is less common when you're talking about variables that are kind of in the first half, but it could be the case that there are so many variables after something that it can't be as late as third, right? There's too many things to its right that force it all the way forward. That's also possible. And in this case, you'd have to have at least 5 things, which is an awful lot. At least 5 things would have to come later than the variable in order to force it in front of the first position. And there is, in fact, one variable that has that, right? H, we already knew, has 6 things to its right on all of its chains. That means that H also can't be third. It can't be as late as third, because it has to come even earlier in the chain. But P and S are the 2 variables that can't be as early as third because they have too many things that push them to the back, and P is going to be the correct answer in this case. Okay. Finally, one last question. We're going to go ahead and label this one again. Also, question 3, if B is before Q and J is less popular than L, I want to make sure I've got the directionality right there. L before J. And this is a could be true question. So here we're going to focus on which variables are constrained but still have some flexibility. As opposed to the first question where we're looking for things that were restricted down to just one spot for a must be true answer. Here we're going to try to see if there's any variables that have some flexibility left, and that'll be the ones that we want to focus on when we get into the answer choices. So V before Q and L before J. Obviously the L before J thing is going to show up earlier in my diagram than the V before Q aspect. So I'm going to go H before L before J. Now I want to think ahead, kind of what else do I know about these variables? L is still before S and V. And V is one of the ones that I care about that's changed. So I probably want to include that next. That is L before V. And then V before Q. Just keep following this line. Q before S. And then Q before P, and I'll come back to that in just a second. So the other aspect here then is I also know how J relates to Q, and therefore how J relates to S. So I'm going to write that in. H before L before J before Q before S. And Q and S are both related to, or P and S are both related to Q, right? They both have to be after Q. But what's happened in this case is I've bumped V up earlier in the process. And if I go back to my main diagram, I know that whenever V is not last, P has to be. Here, V can't be last, so P has to be. That means that P is at the very end of all of this. And the diagram's going to look something like this, this kind of interesting parallelogram shape. Okay, so again, I want to try and condense this a little bit so that I can really focus on where the uncertainty is to try and find that could be true answer. I know H is still first. I know J is no longer an option for second. That means L has to be second. When I get to that third spot, right, H, L, J, or V, there is some flexibility here. So I'm going to write J and V with an arch to show that they are interchangeable. They can be switched. Both of them, however, have to come before these last 3, Q, S, and P, and those occur in exactly that order. And you can see that for 5 of my 6 variables, 5 of my 7 variables, there's no flexibility at all, right? H, L, Q, S, and P are all locked in place. What I want to focus on then is the J and V relationship. And I would honestly just like scan my answers looking for J or V. So I see V here. I'm going to keep going. I just kind of want to see where they show up. I see J and V here and V here. Okay, mentioning both of them, the two variables that I care about, J and V, and saying J is more popular than V, I know that could be true because there is a setup in which it occurs J is more popular than V. There's also a way that it's not always true. It could be V before J. The other four answers here have to be things that can't happen. And we can go through and quickly knock them off, right? So P before S is not possible since I know it's QSP. S before V is not possible because whether or not V is third or fourth, V is still ahead of S. So that's not possible. P before L is not possible because L is now second, and the only thing before L is H. And then Q before V is not possible anymore because Q comes in the fifth spot and V is either third or fourth. Okay, so I hope that was a little more clear representation of how to approach this and kind of the steps to take when you are dealing with these big chains of variables and how to condense them and deal with new questions that introduce new restrictions. I would, again, strongly encourage you to label those new restrictions for yourself, and then try to be very systematic about how you apply them kind of one step at a time without losing sight of what you already know. So for example, this thing, the relationship between V and Q, make sure that you're very systematic here. L before V before Q, which is still before S and P. Hopefully that helps a little bit and may clear up any questions that were lingering after class last time. Look forward to seeing you again on Saturday and hope you have a wonderful week. Thanks.